All right, so what pressure is exerted by 82.5 grams in 70-liter container at 35 C? So pressure, that's what I need to solve for. Volume, I see a liters. In, now this is moles. I don't see a moles. Let's come back to moles. I already know R. And then T is 35.0 degrees Celsius. Now, again, that's not in the right unit, and I can tell that right away, so I am going to go ahead and put this like this as a reminder to myself. So I've used this number and this number. This is related to N. Now, if you remember this or not, hopefully you do. If we use the molar mass of CH4, so carbon is 12.01, and then 1.01 times 4, that's our hydrogens. This is going to give us a total value of 16.05 grams of CH4 per mole. All right, so yes, you can solve it, but again, like, let your calculator do all the work for you all at once. This is 82.5 grams, and then just times 16.05 grams in 1 mole. I know you'd probably love tons of questions where it's just everything's in the right place to begin with, but if I give examples where they aren't all in the right place to begin with, in the long run, it helps you get to that information and just not to get comfortable with the idea that everything's going to be given to you exactly perfectly. So P times V equals nRT. So once we solve for P, so I'm going to divide by V. So I get P is equal to nRT over V. All right, so let's fill it all in. And again, I'm not going to solve this ahead of time. I'm just going to throw it all in the calculator at once. 82.5 G times 16.05 grams in 1 mole. And you can solve it over on the side if you want to. You totally can. 0.0821 liters ATM mole Kelvin times T 35.0 plus 273.15 Kelvin. All of that divided by my volume, which is 75.0 liters. Let's make sure our units cancel. My liter, oops, that's too big. My liters here cancel with my liters there. My grams cancel with my grams. My mole cancels with my mole. And then my, let's see, Kelvin cancels with my Kelvin. So I'm left with ATM, which makes sense because that is a pressure unit. And I can put all this in my calculator all at once. And as a little note, you don't have to have parentheses around things that are being multiplied, only when you're adding like that. So 82.5 divided by 16.05 times 0.0821 times parentheses 35.0 plus 273.15 parentheses. So that whole thing divided by 75. That gives me, I'm going to write a few extra digits, 1.7338. Again, I know my units ATMs, and I'm going to double check. Oops. Let's see. This has 1, 2, 3 sig figs. That has 1, 2, 3, 4. This has 1, 2, 3, but that's a constant. 1, 2, 3. Now, when I add this, I'm actually going to end up with 4 sig figs. 1, 2, 3. So I need 3 sig figs. And the 3 does not round it up, so the answer is 1.73 ATMs. And then we're going to do this one. So I have 0.5 moles of hydrogen gas in 25-liter container at 0 C. What is the pressure? So P, that's again what I'm solving for. V equals 25 liters. N, oh, it tells me it's 0.500 moles. R, I know, 0.0821. And T is 0 plus 273.15. So it's going to be the same rearranging. nRT, solve for P. And I just put my numbers in. 0.0500 moles times 0.0821 liters ATM mole Kelvin times my temperature, which I can look over there and see that it's 273.15, divided by my volume, which is 25, equals, zoom it over here, 0.05. Let me make sure that is 0.05. No, that's 0.5. Do make sure that you copy it correctly. 0.5 times 0.0821 times 273.15 divided by 25. That gives me, let me see. Oh, do you see how I missed my divided by sign? This is something else I try to do, especially with these digital calculators. I end up thinking I've tapped a key and then I haven't. Before I pick an answer, go back, double check that your equation is what you are intending for it to be. All right, so that gives me 0.4485. Notice that this has two sig figs. Rounds him up, 0.45, and when we cancel those units out, I do get ATMs.